Welcome to the another session in Frontiers in CFD. So today's objective is to study the CFD simulation of parallel and counterflow heat exchanger with hot and cold fluid moving from inlet to outlet. Specifically, we are using water liquid as a fluid, hot water as a water liquid, and um, cold fluid again as a water. So what will be the effect of while moving it from one end to other end? How the heat exchange process will take place between water and hot water and cold water, how the graphs are being obtained, so that we are going to see. So the objective is to prepare the geometry of parallel flow heat exchanger with inlet and outlet. The same parallel flow heat exchanger can be turned into a counter flow heat exchanger. Only thing, in the meshing you have to change the cold fluid inlet and hot fluid inlet. So likewise the same task can also be done for the counter flow heat exchanger. Next is to generate the mesh on a computational domain and checking the proper element size, because generating a default mesh may not yields the more accurate result. So that's why we might need to change an element size in between. So this is one of the things that we are going to do. And lastly, to run the setup and visualizing the behavior of hot and cold fluid. So this is the geometry that we are going to follow. A cold fluid inlet from one end through which the fluid is flowing, and then cold fluid outlet, the cold fluid which is coming out of the other end, hot fluid from the left hand side and going towards the right hand side. The same geometry we can follow it for the counterflow heat exchanger also. Total length of is 120 centimeter. So all dimensions are given in 120 centimeter. Welcome to today's session. Today we will see the parallel and counterflow heat exchanger, and we will see how to do the CFD simulation for the same. So first of all, we need to prepare the geometry with the help of ANSYS design modeler. First the geometry has been prepared, then simultaneously we'll go to the meshing and analysis part. So how to prepare the geometry, that we are going to see first. So first of all, go with the fluid flow fluent option, go to the geometry, go to the new design modeler geometry. So the geometry will be prepared from the primitives. First of all, set the unit to centimeter. Then click on any one of the plane. This coordinate system will appear. So this is your X, this is your Y, this is your Z. So accordingly you can see the color combinations available here. So first of all, I will create a primitive, that is cylinder. So these dimensions are as per some reference which are considering. So first of all, make it add to frozen. X component I will take 120 centimeter. This Z component I will make it 0, and the diameter which we want here will be equal to radius equal to 3, so diameter will be equal to 6. So this is what we are proceeding for the first case. So let's make it generate. So this is one cylinder which we have generated with a diameter that is equal to 6, and the length of the cylinder is considered to be equal to 120. So with this we'll proceed. Now there will be some inlet and outlet for the fluid which has been flowing. So accordingly I will put the inlet and outlet for especially the cold fluid, and that's why I need to create some primitive, that is cylinder. Now the cylinder is oriented in this direction, so I don't want it this direction, I want it in Y direction. So I will create the cylinder. So I will put the instead of add frozen I will make X component I will take 1.5 centimeter, Z component I will make 2.5 centimeter, Y component I will just check it 2, Z component will make it 0. Now I need some different radius, so I put here radius to be equal to 1, and let's make it generate. So here you will see from the top also this will be acting like an inlet for us. So again the geometry is not yet completed, so once the things are completed then we'll be able to understand it quite better way. So one more time, create primitive, that is cylinder. Instead of add material I will make it frozen. So radius is 1 as it is. X component, now I will take it 118.5. So it will be on the other side. Next is the component that we required. So we required the Y component. So I'll put it minus 2.5, and the Z component here I'll put it minus 2, and this will I will make it 0. So accordingly now it will be available here. So let's make it generate. So one more time, just cross check it in order to see it is as per our requirement. So just we have to first try to have inlet outlet. Okay, so whole geometry has to be prepared yet. So remaining part of the geometry we will prepare with the help of sketch options. So I will go with the YZ plane. I will look at the YZ plane, and on this YZ plane I will go on to prepare some kind of sketch. So let's proceed with the sketch on YZ plane. So this is your sketch 1. I will create a circle from the center here. The diameter I will take it point, sorry not point, I will take it 5.8. So make it generate. So it will be somewhere here. Okay, so this is the first sketch we have prepared. Then one more sketch we'll prepare. So in YZ plane I will create one more sketch. This is sketch 2. Now this will correspond, so again I need to draw a circle. So just draw a circle from the center here. Specify the dimensions for this. So I will specify this is as 4.2. So this is the second part we have specified. So one more sketch I will require in YZ plane, so that I will generate by drawing circle here. I will draw next one, then this will be putting equal to 4. So these are the purpose of drawing this sketch is to make the object has a pipe of thickness, then there will be a layer through which fluid is flowing, and then again the inner pipe thickness, and then again the inner fluid which is flowing. So that is the purpose over here. So we have prepared 3 different sketches with some diameters. So now I will create some planes on the inlet and outlet portion. So just visualize it in better way. So one more time, I will create first new plane. I will select from face. So I will select the base face here, make it apply, and I will first I will make it generate, and on this I will prepare a kind of sketch. So this is your new plane, plane 4, on which I will draw a circle here, and you will specify the dimensions of that here. So the sketch will now corresponds to 1.8 as a diameter. So slightly zoom in order to visualize it in better way. So this is also to provide some kind of thickness over here. That's why this is done. Same way we have to do it on the other side of our heat exchanger. So slightly turn it in a proper direction and go to plane. So here you have to select from face and select this face. Make it apply. Okay, let's make it generate. So on this plane I will generate a sketch. So for this sketch, one more time draw a circle here. So we will define the dimensions of this again the same as the previous one which we had took. I will take it 1.8. So we are done with the sketching part for the pipes as well as for the inlet and outlet. Okay, now we'll proceed for the next part. So if you remember, I have generated sketch on YZ plane. So I'm just looking this plane again, and now I will do extrude operations. So I will extrude. Now first of all I will start with sketch 1. Instead of add material I will make it slice material. How much will be the depth I want? I want 120 because the length of the pipe is 120. Now here it is showing 3 parts as of now. One this, second for your inlet and outlet, second and third. So let's make it generate. So you can see now the parts has actually increased. Okay, so this is how one by one we will do. So one more time I will do one operation which is called as extrude, but now this will be with sketch 2. Here also you have to do the slice operation, and let's make it generate. So you will see 7 part 7 bodies. So one more time extrude operation. Here now sketch 3, make it apply. Instead of add material, make it slice material, and then generate. So you can see now 8 part 8 bodies. So last slice operation, extrude operation we have to do. So make it apply. Instead of add material, make it a slice material. X component will be 120. So now it is showing total of 8 part 8 bodies for us. Now some further operations are required in order to make the, because there will be different zones here. So each zone will represent its specific thing. Like this is a zone where the fluid is likely to flow. So this is the solid portion where the fluid is likely to flow. This is the portion which is called as the thickness of the hot fluid which is flowing. So hot fluid will be flowing here. This is the thickness of pipe. There will be a cold fluid and the thickness of the pipe which is on the either side. But here now it is showing some 8 part 8 bodies. Some of the parts which has been divided here. So that's why we might need to do some modifications out there. Okay, so before doing this, what I will do, I will uh, create some plane in order to make this as a complete closed portion, and this is as a open for fluid flow. So create new plane. I will say from plane, I will select the YZ as your base plane, and I will make it offset Z here by, I'll make it offset Z by 0.25, and let's make it generate. And I will do one operation which is called as slice. Make it apply and generate. So what this slice operation will be, it will be by for the plane which we have generated. Now similarly we will do it at the other end. So let's look at from the other side. Now one more time create a plane here. So I'm selecting the offset as YZ, make it apply, make the offset Z. By now distance equal to 119.75. Total distance is 120, so that's why I'm taking 119.75. Now do the operation which is slice. So here you can see the slicing has been done. Now it's a very important task, the one which we are observing here, 16 parts, 16 bodies. So we don't want that much number of things available, because it is likely to make so much of complications, and to avoid this we are going to do some basic things. So first of all, observe this here. So I may need to do the boolean operations for, let us say, one or more time, but to avoid the chances of error I will like to do this. Okay, so one more thing that is left is I will go with the extrude operation. Now this is for your the sketch which is generated on planes. So make it apply. Instead of add material, make it slice material. And now I will offset this by distance that is equal to. Okay, so we will extrude this by equal to 2, and let's make it generate. So here you can see the extrude operation has been done. I will just show you the part first. Here the extrude operation has been done. Similarly, the extrude operation will be done at the other end. So click on extrude. Now geometry will be your sketch related to your plane 4, sorry, plane 5. Make it apply, make it a slice material. Again it is 2. So see on the other side, here you will see the object. Now it's time to specify the things properly. So we might need to do some boolean operations. So to understand it in better way, I will do the first boolean operation, and then I will do the other boolean operations. So first of all, what I will do, I will select this outer faces here, this one, this one. Only outer faces I am selecting. Same way on the other side. Outer spaces means more about which is related to the outer casing of the pipe, where the cold fluid will be flowing, and that's why only this part I have selected. And now I will make this as a boolean. So create, go to the boolean and make it apply. So now this will become a one part. So purposefully I have not selected this because this is your fluid flowing zone, this is your casing here, okay, and this is your the second part. So this is the first part we have made as a one part. So you can see here. Now I will make this to be equal to hide. So if I make this equal to hide, so what will left with us is the fluid zone. So this is a fluid zone which is available with us. So one more time, just check it. Okay, so this one and this one I will select, this one also I will select, and go to the boolean operation, make it unite, and then generate. So just carefully visualize it. If something is left, that we have to also select it again. So what I will do, I will hide the internal zones. I will hide this body. This body also I will hide, so that I will be left with only the portion which I want. So this is all fluid zone. Similarly, on the other side also I will do, because there was one layer which we need to hide it. So I will just try to show the layer, this one, only this one. And this is the internal part. So what is left is only your fluid zone. So I will just select it and create the Boolean operation, make it unite. So you might need to do this operation one or more time, because you need to match the fluid zones and you need to match every zone, so accordingly the number of operations may increase. So I will make it show all bodies now, and one more time let's zoom into the body. So this is your outer part. This is your the casing. This is the zone where the fluid is going to flow. Okay, so the fluid is actually now divided into two parts because of the slice operation done. So one by one I will hide the bodies which are not required as of now for us. So this is your fluid zone. So first of all I will select the outer one, and then I will select the internal one. So this is for your casing. So go to the create, do the Boolean operation, make it unite and generate. So now this is the outer layer. So I will hide this one more time, so that I can select 3 layers for your fluid. So create Boolean, make it unite, ensure that there are 3 bodies. So now what we left out is only 4 bodies. So I will make it show all bodies now. So this is the one which is related to your outer casing of the pipe. Then this is the fluid through which it is flowing, which is flowing through the outer casing. Then this is the inner casing, and lastly it is your fluid which is flowing. So the central fluid is your hot fluid. So you may specify either hot fluid and cold fluid over there. This is your outer pipe. So you may specify this outer. So this is the cold fluid which is flowing, and this is your inner casing, or you may specify inner pipe. So I will just one by one will show you one more time just by zooming into the particular part. So this is your all outer pipe. This is the cold fluid that is going to flow. This is your inner pipe, and lastly your hot fluid. So wherever fluid is there, you need to define the fluid zone. So let's make it same way here. Hot fluid, you have to make it fluid zone and then generate. Once this is done, you can actually proceed for the next part. that is related to mesh. So we have generated the required regions now. Now it's time to proceed for the next part. So first of all, I will try to save the work. So I will specify this here. CFD, simulation of parallel flow heat exchanger with hot pipe copper, cold pipe aluminum. So go inside, give the same name here, and now go and save. So it may take some time. Open now the mesh part. So we'll try to first generate the default mesh, then we will visualize how good the mesh is. If it is not satisfied with us, we'll try to go with some finer size of mesh. So first of all, we'll try to generate with the help of default mesh. So the default mesh may not be that proper. So we will check whether it is as per the requirement or not, or whether we are likely to get some better result or not. If you find it not that good, we can continue to make it finer. But let's visualize the statistics also. Right now it is 43,527. So I will um, go with some 0.00, let us say 25, and let's make it generate. So depending on whatever the finer size you are going, the time requirement will be more. So we must want a mesh which is a better, so that the accuracy of the result will also be better. As we took slightly finer, it might take some time. If your computer is not able to handle it, probably you reduce the mesh size. Okay, so in my case, it has work. So around 5,72,232. So it's quite better mesh which I have generated. Now I will just specify the inlet and outlets. Actually, I am interested in this part. Yeah. So I will specify here as create name selection. I will mention cold inlet. This one. And this is your hot inlet. Or you may first specify this is hot inlet and cold inlet. Next, let's zoom in. Okay, so this is, I will specify the hot, sorry, cold outlet. Now cold outlet means the temperature of the fluid might have increased, but specifying the cold and hot fluid, that's why I am making it hot outlet, cold outlet. Okay, so we are done with the name selection. Hot inlet, I will just show you. This is hot inlet. cold inlet, then there is hot inlet here, then there is a cold outlet and hot outlet. So definitely what will happen, if the cold fluid is coming here and moving here and it is coming out, so definitely it will become slightly warmer. But for understanding, I am putting the cold inlet and cold outlet. Similarly, hot inlet is coming here, hot inlet will go out. So initially it may be at higher temperature, after that it may be at lower temperature. So it may be called as warm. So we'll click on update. So the mesh translation to Fluent successful. So if you are satisfied with this mesh, you can go ahead. If you are not satisfied, change the element size. So now let's click on setup and then click on edit. So double precision I will put the even number of processes a computer can run. So it may take some time depending on the capabilities of your computer. Okay, so till the time the object doesn't load, you cannot proceed further. And at the same time, you must see such kind of arrows. This is for your cold inlet, this is for your cold outlet, this is for your hot inlet, and this is for your hot outlet. So everything should be visible out there. So now I will select the transient one, then gravity, I will put it minus 9.81. Then I will go to the models. Only I will turn the energy equation on. Click on this OK. In viscous, I will go with K epsilon, then enhance fault treatment, thermal effect, and curvature correction, and then make it OK. So once this is done, you will go to the next part, that is related to material selection. So materials can be selected from the Fluent database. So I'm not going to use air, I'm going to use water liquid. So I just click it here, water liquid, make it copy and then make it close. So by default option is air, so it will remains as it is there. So by default option here is aluminum, but we are going to use aluminum at one place, so that's why I'm keeping it there. So go with the solid, and the hot fluid will select copper. A hot we say the pipe will select as copper. So we have three fluids with us: water liquid, copper, and your aluminum. Now let's go to the cell zone condition. So here you will see cold fluid, hot fluid, inner say pipe and outlet pipe, outer pipe. So just go to the cold fluid. So which is your cold fluid? Water liquid. So select that, make it apply and then close. What is your hot fluid? Again it is a water liquid but at different temperature. So you need to select water liquid, make it apply. Okay, now same way you have to do it for inner pipe. So what is the inner pipe? We are considering it made up of copper. So I selected it as a copper. Outer pipe I will keep it as aluminum. So I am keeping the same default option available. Okay. Next is your boundary conditions. So cold fluid inlet. So we'll put actually you can put velocity, but I will put mass flow inlet. Okay, so what is the value I'm going to use as a mass flow inlet? So for cold fluid, I'm using 0.056 kg per second. Make it apply. So there is one thermal option available. I'm not going to change this. I'm keeping it as it is because I'm expecting the cold fluid to be at maybe around 27 degrees Celsius. So that's why I'm not doing anything. But for hot fluid, I will be doing this. First of all, specify the, again, not velocity, just change the mass flow inlet. say 0.01235. So here thermal will select the temperature of the fluid which is been coming. So I will take the temperature maybe around 70 degrees Celsius. So I will take it around 343 Kelvin. Make it apply. It means the hot fluid will come at 343 Kelvin. Okay. Resting is the wall outer pipe. So I will select the wall outer pipe. You know it is made up of aluminum. I will keep it as it is. Then wall inner pipe. You know it is made up of copper. So make it copper. Okay. So in this way we have specified the inlet and outlet as well as the material. Okay. Now I will go to the, we already put the boundary conditions. Now I'll go to the report definition. Actually I want surface report area weighted average. Where I want at total temperature at outlet. So total temperature at cold outlet first I will select. I'll make it cold outlet. So carefully observe, I selected only cold outlet. One more parameter, area weighted average. I will select temperature, here total temperature. Now I'll make it hot outlet. So here hot outlet. So earlier was report definition 0. I will make it this is 1. Make it OK. So let's close this now. Now click on initialize. I click on the initialize. Go to the calculation activities. So let's say I put it 20. Go to the solution animation. So go to the new object. Here temperature, put as a total temperature, select all. The color map option, I will take it float, make it apply here and then close. So I selected each and everything. So this is actually we are visualizing the total temperature of the system here. So make it close, select this. I will say total temperature animation. Actually this is not that useful here because the hot fluid is there and then the cold fluid is there. So one or more layers are there. So it may not be that effective to go with. So even if it is not set, still it is okay. So go to the run calculations. Go to the number of time steps. Let us say I put it initially 100 and let's make it calculate. So we'll wait some time. Once the process is completed, you can see the report definition chart will be available now. What is the temperature at outlet? So that is going to be visible. So this may take some time. Um, Once the report definition things are generated, we'll let it to run it maybe for 100 or more number of time steps in order to visualize the result in better way. So let it to run. So once these four are completed, you will see the report definition options available. So that will show you the cold fluid inlet and hot fluid, cold fluid outlet and hot fluid outlet temperatures. So there may be some slight increase in the graphs which is happening. So this is how the curves that are going to be visible. This is your scale residual, and we'll just wait for some time in order to visualize the things, because this is the very early stage which we are running. So we might need to run it further in order to check how the things are proceeding. If possible, we are able to see some variation, especially in the outer region, outer surfaces. But here, say, it may not be that proper what we visualize in the result section, but still we can visualize some of the part of it. So we are around 96 time steps. So we might need to run this further. Just for information, I will just show you the scale residual, then some total temperature at the outlet for the cold fluid. This is how the variations are there. So at max it reached to around 316. Similarly, some slight increase as observed, and now it will become flat. So this is how the temperature variation this is there. So we might need we are in it very short time as of now, so we might have to run this further in order to visualize how the temperature variations are going to take place. So once this is completed, we'll run it further, and accordingly we'll check the results. Maybe we'll run it for around 400 to 500 time steps, and after the 400 to 500 time steps, that will be around 500 seconds or around 600 seconds. Then we'll try to run the simulation with the help of the result part. So this is how the iteration which has been performed by us. I will just open the set result part in order to just visualize the things. We might have to run this further in order to visualize it quite in better way. But let's have initial visualization on how the fluid is flowing from inlet to outlet. So here we have, so I put it cold inlet, cold hot inlet. So I'm just specifying the names. Okay, so one by one I will just make it some transparency. I'm setting, say for everything. Then hot inlet, some transparency. So this is just to visualize it in better way, no other work of this. Or even if you directly go to the volume rendering, you don't need to do these things again. And this. Okay, so this is how the few things are there. So if I go with volume rendering, this is one way of visualizing. Let us say temperature, local, I will say, let's put it to 100 resolution and just visualize the things. So this is just for the temperature. Then in addition to this, there is the streamlines which we can visualize. So first of all, we'll just check it out, this one. It may not be have been fully developed because we are not performed the simulation for some longer time, so we might need it to run it further. So but whatever is available up to this, that we'll try to visualize. Okay, so this is one of the variation which we can observe in terms of the contours. I will just slightly make the contours better with some more number of value tricks and with some better aspect ratio. So if you put it maybe with some more resolution, you may observe it more better way. So I will just keep it here. Okay, this was regarding to the temperature volume rendering. The most important part which we will like to visualize is this temperature streamline. So we need to go with the streamline part for this. So we need to tell there are two inlets now. So hot inlet for us, and here you need to change the variable to temperature. So instead of global, I will put it local. So number of particles I will put it maybe around 40, and let's play. Let's keep it here. So volume rendering just now I will close for a while. Then this is first streamline. One more streamline I will put. Now I think first one we took it for hot inlet. Now I will put it cold inlet. This is a cold inlet. So change the variable to temperature. Put it local, and then maybe the number of I will put it 40. So make it check it here, and let's put it. So this is regarding to the particles which are coming in. So for temperature streamline, so this is temperature streamline 2. Now this can be visualized with the help of simulation. So I will go with the sweep animation. This is temperature streamline 1, and I will select both of them, make it slow here, and I just visualize it for the this particular case. Okay, so we have the part. Okay, I will just make the particle size to be smaller so as to visualize it in quite better way. Okay, just go inside. Symbol size I will put it to somewhat lower value here. So now visualize this. So some of the particles are for the centers, and some of the particles are coming from the top. So those who are living here, they are the cold particles, and those who are moving straight, they are the hot particles which are moving. Initially was hot, and then they are moving towards the we can say to the right hand. Those who are coming here to here, so I will just reduce the number of particles so as to visualize it in better way. Or let's visualize with some different, sorry, we need to stop. Yeah, so one more time with a different angle I will try to play. So the cold fluid, and then there's a hot fluid which is flowing. The hot fluid is actually moving at the center. The color combination of the hot fluid is also changed because it is exchanging heat with the we can say the cold fluid. So if you see at the inlet, the cold fluid was there. So they no longer remains sorry, not red, blue. They slightly become a different color, so that which we can visualize. So if I um, want to individually see this, so this is also one of the way I can do it. Say one by one I will see. let this to stop first. Okay, so streamline 2, 1 we will observe first. This is for your hot fluid which is coming from here, coming to the other end. You can see at the start there is a red color. Now the color combination has changed. Here you can limit yourself to less number of particles also in order to visualize it in better way. So now I will visualize the second streamline which actually relates to the cold fluid. So once this is stopped, I will run the second streamline, and you can run it simultaneously also, depends. So simultaneously you have to carefully observe it because of limitation of the size here. So now let's see the particles here which are coming from the top. Initially they were blue, now they are going to change the color. So because of the color combination we can see what is happening to hot fluid and what is happening to cold fluid, which we can see. Okay, so this is how both of them also can be visualized. You can see the video file of this also. Or even you can turn the temperature volume rendering also on. We have turned off the temperature volume rendering as of now, but we can make it on also. So both of them, let us say if it is there, and if I select this one, so you may see maybe slightly with some better way, but only the particles may not be visible, or visible maybe may not be completely. So volume rendering along with the temperature and streamline 1 and streamline 2, both of them we are able to visualize. So let's put it some proper place once this is stopped. So till the time all the particles are not coming, this will not stop. So we have to wait. Okay, so make it properly place. If it is possible, may have some bigger size also. And one more time we'll play. So you can see the particles how they are moving. This is along with the volume rendering also. Streamline 1 is also visible, streamline 2 is also visible. Some temperature is also visible in this particular case. Okay, now next thing I will show you how to plot the charts for this. So once this is stopped, we'll show you how to plot charts individually for streamline 1 as well as individually for streamline 2. So we have to wait till the last particles are going out. Okay, the particles has gone. Now there is one of the important tasks which we want to visualize. I will just save the work before proceeding so that I can access it later on. Here in the workbench window also I will save it. Okay, the Fluent window is as it is as of now. Now what I will do, I will just okay, I was thinking of charts. I will just show you the charts. So data series is there. So first one I will take streamline 1. I will add the data series here. Second one I will make it streamline 2. Then one by one I will specify chart count. Now on chart count I will put X because in X direction the fluid was there. So here on Y axis you will be having temperature. Let's make it apply. So in this way you can actually visualize the uh, charts which are related to temperature. So one series 1 and series 2, both of them are there. If you know series 1 is your this one streamline 1, series 2 your streamline 2. So you can actually visualize this, how the hot temperature has been varying, how the cold temperature has been varying, so that we can visualize. So normally the hot fluid temperature should go down. That trend we can observe here, and the cold fluid temperature should go up. So that is one of the trend we can observe, but still we have not done it for many time steps, so we can go with some higher number of time steps in order to visualize it in quite a better way. Let us say I don't want to observe that many particles. You can actually go and reduce the number of particles in streamline. I have selected 40. You can go with click it here and change the number of particles here also. So let us say we don't want 40, I want only 20, and here in the streamline also I will just want 20. So make it apply. The changes here will also the same appear. You will go back to this also. So you can see various things can be easily available, and we can visualize. Even we can save the video file also. So first of all I can stop the, this is just a volume rendering if somebody want to visualize. If somebody wants to visualize both volume rendering along with the temperature streamline, you can save it like this, maybe with some better resolution on the screen. And let's save the file here. We are running it both, and go to this one. I will select the higher resolution, say 3840, and this is your 2160. I am going for 4K resolution. Highest I will put it 60. Save image as a file. So output directory. Preferably we'll save it the location where we are doing the work. Just search for parallel and counter flow. Okay, I will just create one more folder here. Later on we can copy also. Okay, parallel and counter simulation. Save as. Here also you will save. You need to save it. I will search for parallel and counter flow simulation. Make it open. Save it and just click on this